We're now going to look at some standard formulae for integration when we're using trig or hyperbolic functions. These formulae can all be proved using the techniques that you saw in the previous video, and you'll find them in your formula booklet. You should recognize these now, and here are the various integrals. Sometimes two forms. You may use these at any time unless you are told to use a substitution to prove or equivalent. Let's see how we can use one of these in this example. This integral, 1 over the square root of 9 minus 4x squared, isn't exactly in the right form. So what can we do in order to use this standard integral to help us integrate this one? Just pause the video and see if you can sort out for yourself what to do with this. So pause the video now. Well, did you manage to sort out a way of solving this? We really want the x squared on its own. So if we take the 4 out, we get 1 over the integral, 1 divided by, taking the 4 out through the square root becomes a 2. Inside the square root, I'm going to have 9 over 4 minus x squared dx. Just convince yourself that that is the same thing. 2 is the square root of 4. Multiply it in, you get 9 minus 4x squared. Well, that's nearly written in the right form. We need to have a squared. We should be able to see what a is, but let's just emphasize it. Let's take the 2 out, a half, integral, 1 divided by the square root of 9 over 4 is 3 over 2 squared minus x squared. And now we have the thing in the right form. That is 1 over a squared minus x squared. So the answer is 1 over 2 arc sine x over a, that's x divided by 3 over 2 plus c. Not difficult, and if you can rearrange your integral to one of the standard ones, then you can quote the formula. One more. This one, no square root sign. So the most similar one that we have in our standard formulae is the integral of 1 over a squared plus x squared. Well, stop the video again and do this problem for yourself. Okay, did you manage it? You should have realized that you're taking the 9 out. So this is going to be equal to 1 over 9 integral 1 divided by 5 over 9 plus x squared dx. Multiply the 9 back in. Yes, it works. We need 1 over a squared plus x squared. That is 1 over 9 integral 1 divided by, slightly more awkward this time, root 5 over 3 all squared plus x squared dx. So a is root 5 over 3. This is going to give us 1 over 9 times 1 over a is 3 over root 5 arctan x over a is 3x over root 5 plus c. Tidy it up. 1 over 3 root 5 arc tan 3x over root 5 plus c.